Okay, we're going to continue section 6.6. We talked about trapezoids yesterday, and today we're going to talk about things called kites. So we're going to go fly a kite. Not really. It'd be a nice day to fly a kite, though, wouldn't it? But we'll learn a little bit about what a kite is. So let's just happen to have a kite sitting right here. Isn't that nice? It's convenient, isn't it? And let's talk a little bit about what a kite is. Let's talk about the definition first of all. First of all, the definition of a kite, it's a quadrilateral, all right? Actually, let's do this. Let's get rid of this thing right here, and let's get rid of this thing right here. Okay, there's a kite right there. So those two lines really weren't part of a kite. We'll talk about those in a second here. But this is a kite right here. And let's change colors. What we're going to do here is just define a kite. What is a kite? Well, it's a four-sided figure, right? So what's the name of a four-sided figure? It's a quadrilateral, right? And what happens here is this: the definition says it's quadrilateral with exactly two pairs of consecutive congruent sides. Now, that's a lot of words, but what does that mean? Two pairs. So there must be two pairs of sides, right? So there's four sides altogether, right? So two of them are equal, and then two other ones are equal. Right? So which ones are equal? There are exactly two pairs of consecutive congruent sides. Consecutive means one right after the other. Are they talking about this one here and this one right here? No. Nah, because that one looks a lot longer than that, doesn't it? So what's equal? This one and this one right here. Everybody see that? Let's label it so we don't have to say this one here. Alright, so AB and AD are equal to each other. They're consecutive sides. They're next to each other. And these two sides are equal to each other. It says there's exactly two pairs of consecutive congruent sides. So what do you think the other pairs would be? It's pretty obvious. What? BC and DC, right? The other two sides, exactly right. Does that make sense? All right, so that's what a kite is. Two pairs of consecutive congruent angles. Not AB and BC, they're not equal, and AD and DC, they're not equal, but these two are equal, and these two right here are equal. Well, that's not the only thing we know about kites. We know some other things. Let's take a look at the angles. Remember on parallelograms, you had two pairs of equal angles, right? The opposite angles were equal. It's not exactly true here on a kite, but about half of it is true. You do have a set of angles that are equal, just by looking at it. Now, I know I told you before, don't always go by what it looks like, but in this case, it works, okay? So which angles look equal and which angles don't look equal? B and D look equal, don't they? Yeah, I agree with you on that. So we're going to mark them equal, and that's exactly true on this. Now, how do I know which ones are equal? Okay, what if I had it drawn so I couldn't really tell? Well, here's a good way to tell. Do you see how I have all the sides marked? Do you see this side and this side are not equal to each other? And this is the angle that connects those two, isn't it? All right, so the angle in between, or the angle that connects the two non-equal sides, do you see that? Hear what I just said? The angle that connects the two sides that are not equal to each other, those are the two angles that are actually equal. Get it? So this connects the two non-equal, this connects the two non-equal sides. Those two angles are equal to each other. What does this angle right here connect? It connects two equal sides, doesn't it? And this connects two equal sides. They are not equal to each other. So this angle A is not equal to angle C. And it's pretty obvious on this picture right here that this is quite a bit smaller than this angle right here, isn't it? All right. So on a kite, you have one pair of equal angles, but the other pair are not equal. On a parallelogram was different, wasn't it? Both pairs of opposite angles were equal on a parallelogram, but not on a kite. We good so far? Okay. Let's talk about. Let's do the. Now it's time for the diagonals. So let's do that in a different color. Let's do the diagonals. So if I go from B to D, that's one diagonal, and then if I go from A to C, that's another diagonal.
Wait,
you sure? Right, in this one there are though. Alright, so let's take a look at this. I put some diagonals in there. We know about diagonals. We've been doing those all through parallelograms and squares and rectangles and rhombuses, or not rhombuses, what is it, rhombi, and all that. Okay, so we've done a ton of diagonals, and these are diagonals of a kite. Now let's take a look at the diagonals of a kite. Is there anything that you might just guess by looking at the picture? And you're probably right. If you look at the picture and just kind of guess that that's true, it probably will be true on this. What is that? Yeah, it's good. That's perfect. Okay, it took me a long time to get the other class to see that, but you saw it right away. Look at the angle in between. All right, that's the intersection of those two diagonals. You've got a right angle. So what do we say about the diagonals of a kite? They are, one word, perpendicular. Very good. Okay, so the diagonals of a kite are perpendicular. Everybody got that? Okay, and that's very important. It's always going to be true. Okay, every time you have a kite, the diagonals will always intersect at a 90-degree angle. So they'll always be perpendicular. And that's really, really helpful. Anything else looking at it that you might think might be true? There is something about a midpoint. What is it? We'll call this point E right here.
Yeah, BEC is equal to EB.
You sure? I don't think you're saying what you want to say. You said BEC. That's an angle. That's this angle.
Is it not equal to the other one?
Well, all four of these are equal. If this is a right angle, all four of these are right angles, and they're all equal to each other, yeah. But what else about the diagonals themselves do you think might be possibly true?
The distance.
It looks like C CE.
It does kind of look like it might be, but yeah, there's no real relationship between that. But there is another relationship. What is it? Look at this. Yeah, BE and ED are equal to each other, exactly. I'll put 3 tick marks here and here. So this one's actually being bisected. Okay? How do you know which one is being bisected? It's the one that connects the two equal angles. Everybody see that? So the one that connects the two equal angles, that thing is being bisected. The diagonals don't bisect each other, do they? Because look at AE and EC. Do they even look close to the same? No, this one looks way longer than EC does. So they don't bisect each other, but this diagonal right here does bisect BD. So this is being bisected, all right? So it splits BD right in the midpoint. You see it? Okay. What else possibly could look true? Now we said that angle A, the big angle A, and big angle C, they're not equal to each other. But what do you think what does it look like that diagonal does to angle A? It does, and that's exactly right. It bisects it. So this angle and this angle would be equal to each other. And what do you think would be true about angle C? That bisects that as well. Everybody see that? What about up here at angle B and D, though? Does that look like it bisects angle B? No, not at all. Okay, so it doesn't bisect. There's a lot of things to remember, but if you basically go by what the picture looks like, it usually works out pretty good. And I hate to say that because I've been such a stickler for saying don't just go by the looks of the picture, but usually it works out pretty well on a kite. So look at this. This diagonal that connects the two equal angles, it does not bisect that angle. Do you see it? So this is not being bisected, but this one is. Because if you think about it, what do we have here? Look at this triangle ABE. What do you think that might be? What do you think might be true about these two triangles right here? ADE and ABE. What do you think might be true about them? We don't say triangles are equal. What do we say about triangles? We say they're congruent. And here's a reason. Watch. Here's an angle. Here's a side. Here's another angle. Or you could have gone... you could have done this, right? You could have said that that's... You could have gone all kinds of ways. Angle, side angle this way. You could have gone angle, side angle this way. Well, actually, you don't know that this angle is equal to this one. But yeah, you could have gone angle, side angle. These two are congruent to each other. All right? You could have done this. You could have gone side, side, side. Right? Side, side, side. So these are congruent. There's all kinds of things. Well, this triangle and this triangle are congruent. This triangle right here and this triangle right here would be congruent for also. You okay with that? Anything else we're missing? I think we've covered quite a bit. Let's do this. Let's do a quick little example and we'll be finished. I'll tell you what, let's drop this down and just do this. Let's make this a little thicker. There we go. And watch this. What if I said that was 8 and that was 8? This little short part is 6. This longer part is 24. And I call this A, B, C, D. And I'll call this E. And I asked you to solve for DC. So find DC. Now we did something yesterday that we're going to have to do on this. Find DC. DC is this thing right here. Let's just call it X. Is that all right? Just for one letter instead of calling it 2 letters, DC. What do you think? Any ideas? X is equal to D? Well, D is a point. To DA. All right, but we don't know DA. You're absolutely right. They are equal to each other. You're right. But that's not going to help us, though, is it? What do you think? What else do we know? Brianna, what did you say first about the diagonals? You said they're what? 90 degrees. So we got a 90-degree angle there, don't we? Does that help? Think of what we did yesterday. We did some math yesterday that we don't usually do. But Pythagorean Theorem, that's right. Look, I've got a right triangle here, don't I? And I've got 2 sides of my right triangle. I can find the third side, right? I can find the hypotenuse. Remember we did Pythagorean Theorem yesterday, didn't we? Yeah, so it's the second day in a row we've done Pythagorean Theorem. So how do I set this up? I could go 8 squared plus what? 24 squared equals the hypotenuse squared, which is x. Remember that? And then you can just plug some numbers in. So let's see what we get. We get 8 squared plus 24 squared. Okay, that equals 640. But is that my answer? Is x equal to 640? No. X squared is equal to 640. How do I get x by itself? Square root it. That's right. Take the square root of both of those. So let's take the square root of that 640. And we get about 20, we'll round it to 1 decimal place, 25.3. So x is approximately 25.3. And there you go. Does that make sense? Does it make sense that this could be 25.3? It does, because the hypotenuse has to be the longest side of my right triangle. Is that the longest side of my right triangle here? Absolutely. Okay? Does that make sense? Real quick, I know the bell's about to ring pretty soon here, but let's take a look at this. What if I said that this isn't really drawn to scale, but what if I ask you to do this, and I ask you to solve for angle A? Well, I'll just show you since time's running out. Watch. What do all 4 of these angles add up to be? 360. So what's 128 plus 72? That's a 10. That's a 9. It's 200, isn't it? Don't they add up to 200? Yeah. So that's 200. So how do I find this angle? Remember, these two are equal to each other, right? Well, no, not yet. I go 360 minus 200, which is 160, divided by 2, and I get what? That's 80 degrees. So what's your homework? Your homework is to finish those 4 problems that were kite problems on that worksheet I gave you yesterday.